Hi, this is Chris with Sanderson Test Prep, and in our last video we talked about the general shape of Limacon graphs when graphing polar equations. Here we're going to take a look at a couple specific examples so that we can see how the numerical values for A and B are going to impact where our intercepts occur and the more accurate and exact forming of your Limacon graphs. So let's take a look at this first example. We have r equals 3 plus 4 cosine theta. And hopefully by recognizing that we have a positive cosine, we know that we're going to have an orientation that is along the x-axis and it's going to point to the right. And the general shape that we'll see for this is going to be something like this. But how do we know where these actual intercepts are so that we could get more accurate values and overall a more accurate graph? So let's take a look at how we can use these values of A and B in order to come up with this. So first thing to check is what our general shape is. And here, if A and B is less than 1, which it is in this case, A over B, remember these are our A and B values. A would be 3 and B would be 4 for this particular function. So this is going to be 3/4, which is certainly less than 1. So we know A over B is less than 1, which lets us know we're going to have that general shape with the inner loop. And if we're not yet comfortable with that, then check out the introduction to Limacon shapes in our previous video. But here, if we know that A over B less than 1 means we're going to have an inner loop, we want to figure out where these intercepts are. So the value of A is the easiest to start with because that's going to dictate along for a cosine function, it's going to dictate the y-intercepts. So you're going to have a positive and negative 3 for those y-intercepts. Now we want to figure out where the inner loop and outer loop are going to cross the x-axis so that we can make it accurate along the horizontal axis as well. And so the way that this is going to work is that when you have an inner loop, you're going to have your inner loop dictated by the absolute value of A minus B. So that'll tell you the intercept for that inner loop, and then A plus B, we don't have to worry about the absolute value because A and B are positives, but A plus B will tell you the location of your outer loop. So here, if I take the absolute value of A minus B, I get 1. So my inner loop is going to be right there at 1. My outer loop, A plus B, would be 7. So 1, 2, 3, 4, 5, 6, 7. So my outer loop is going to cross there, and then we already know our y-intercepts are based on A. So from here, we can come up with a pretty accurate graph. I'm going to zoom in a little bit to try to make this graph as accurate as possible, but we're going to have an inner loop. Then we're going to cross our y-intercepts at positive and negative 3. And we're going to go all the way to our outer loop of 7. And that's going to be the shape of this particular limacon, which contains an inner loop. Let's take a look at one more example with sine, just to make sure we're comfortable even if we change around the positives and negatives or we change around the trig function to a sine. So here we have r equals 2 minus 5 sine theta. And this one I'm going to go through a little bit quicker just to make sure that we're on our toes. So here, A over B would be 2/5. So that lets me know I'm going to have that inner loop shape. And it's a negative sine function. So that lets me know the orientation will be downward direction along the y-axis. So we're going to have something that in general looks like this. But let's see if we can come up with more exacting values. So here the absolute value of A minus B would be 3. A plus B is 7. So that lets me know in that downward orientation, my inner loop is going to cross at negative 3. My outer loop is going to cross at 7 in that downward direction. So that'll be a y-intercept of negative 7 when we go down by 7 units. And then our value for A, remember, told us the intercepts along the opposing axis, which in this case will be the horizontal axis. So we'll have 2 and negative 2 as our x-intercepts in this case. And now that we have those 4 key points, we can go ahead and try to draw in our limacon. So here we're going to have an inner loop, and then it's going to have these particular x-intercepts, and this would be our final graph. So hopefully that makes sense in terms of how we now numerically use the a and b values in order to graph a more accurate version of the general shapes that we looked at in our last video. For more examples and some cases with the other shapes like cardioid structures, take a look at our other videos, and thanks for watching.